Hi, welcome to Min to Max Math, where we make math make sense. In this video, I walk you through how to solve derivative problems using the chain rule. This rule helps you take the derivative of a composite function when a function is within another function. So this right here is how the original function looks like. This is our composite function where we have an inside function within an even bigger function. In this case here, what I wrote in red here, which is the g function, is our inside function, which is inside an even bigger function, which I refer to as f. To take the derivative of this composite function, we first take the derivative of the outside function, but remember to leave the inside function alone. Then multiply that by the derivative of the inside function. To rewrite this in the English language, we take the derivative of the outside function, but you leave the inside function alone. Whatever that turns out to be, multiply that by the derivative of the inside function. Let's take a look at our first example. In this first example, we have the square root of 3x squared plus 2. Let's first rewrite this original problem so that we are no longer dealing with the square root symbol. To rewrite this, we'll have parentheses around the inside function of 3x squared plus 2, and that is going to be raised to the 1/2 power. Okay, so the inside function is 3x squared plus 2, and it is inside an even bigger function, which is the function that is raised to the 1/2 power. Now let's follow this formula to help us take the derivative of this composite function. I rewrote the formula here to remind you how to use the chain rule. So take the derivative of the outside function first. So the outside function is this 1/2 power. So we'll use the basic power rule. We'll bring this 1/2 power to the front so that we have 1/2 as our constant. And remember, the power rule says to reduce the power by 1. So that is 1/2 minus 1, which is -1/2. And again, we leave the inside function alone. Again, the inside function is 3x squared plus 2. Then multiply this whole thing that we just wrote by the derivative of the inside. So again, we take the derivative of the inside function, which will come out to be 6x. Now let's simplify our expression here. Excuse me. Once we've simplified our expression, it will turn out to be 6x over 2 times 3x squared plus 2 raised to the positive 1/2 power. Let's simplify this some more. So we have 3x over the square root of 3x squared plus 2. There's nothing else left to simplify, so this right here is our derivative using the chain rule. Let's take a look at our next example. Here's our second example. This is another composite function where the outside function is this exponential function and its inside function is this polynomial here. The rule doesn't change, so we will first take the derivative of the outside function. So take the derivative of this exponential function, and again, leave the inside function alone. Next, multiply this whole thing by the derivative of the inside function. So the derivative of this inside function becomes 2x plus 5. There's nothing left to simplify, so you can leave your answer in this format. Now let's take a look at our last example. In this last example, it's a little more complex because we'll have to use the chain rule twice. So we're using the chain rule twice because within our outside function of this natural log function, we have two inside functions. The sine function being the next inner function, and the most innermost function is 2x. The rule stays the same, so let's use the chain rule. Take the derivative of the outside function, which is this natural log function. So if you remember, the derivative of the natural log function is 1 over whatever is inside the parentheses, which is sine of 2x. So remember, take the derivative of the outside function, but leave the inside function alone. Once you got that down, multiply that by the derivative of the next inner function, which is this sine function, but continue to still leave the inside function alone. So remember, the derivative of the sine function is cosine, and again, leave the inside function alone. And we have one more inner function to deal with, which is this 2x. So multiply this whole thing by the derivative of the innermost function, which is 2x. And so the derivative of 2x is just 2. To clean up our work so that this looks nicer, we have 2 times cosine of 2x all over sine of 2x. To make this look nicer one more time, remember that cosine over sine is the same as saying the cotangent function. So this becomes 2 times the cotangent of 2x. Our answer is in its most simplest form, so this right here is our derivative using the chain rule.